Here's an example about finding the area of a sector of a circle. The sector has a central angle 45. That says 45 degrees. It's funny notation here. Find the area of the sector if the radius is 10. Okay, so let's take a look. Let me draw for you a circle. Whoops. Never mind, I didn't have my tool on. So that's Mr. Heron's freehand drawing, which is not nearly so good as the tool. There we go. All right, so when we have a circle, here's the center. So if we're talking about an angle of 45 degrees, so here, it's about like that, right? 45, so there's a 40, that's what this says. I should change that. That's 45 degrees. So 45, so here's a 45 degree angle. That's the opening between those two sides. They're asking us to find the area of the sector. So two things we've learned. There's a formula we got earlier for this, right? And that's the arc length. The arc length, we call it S for I don't know why, is r theta, and then the area, so if we come in here and we do the area, let me see if I can do that a little differently. So the area, formula, area A is a different formula, 1/2 r squared theta. So that's what they're asking us for on this problem. I just wanted to give you both formulas to have both of them before you. They're not asking me for arc length on this one. But here's the crucial fact. You hear this. For both formulas, theta must be in radians, not degrees. So you can, if you have degrees, you got to change it to radians to use the formula. Both these formulas, S equals r theta, arc length, and A equals 1/2 r squared theta, area of a sector of a circle, has to be in radians, not degrees, for the formulas to work. Okay, so they want us to find area. Let's grab the area formula over here. Area equals 1/2 r squared theta. Now they're giving me an angle of 45 degrees, so right off the bat, I've got to convert that angle, don't I? I've got to take, so step one, change 45 degrees to radians. So how do you do that? Well, it's a unit conversion. Put it over 1. And then you put on the bottom what you want to get rid of. I want to get rid of degrees. Remember the connection between the two worlds? 180 degrees is pi radians. That's the bridge between the two worlds. So 180 degrees goes on the bottom. Why? Because you want degrees to cancel. So you got to cross cancel. So pi radians on the top. So then you just go straight across the top. That's 45 pi straight across the bottom, 180. That's going to be radians because we got rid of degrees. See how degrees cross canceled? So we're in radians now. Now we can reduce that fraction. If you use your calculator, 45 goes into 180, I think 4 times, right? Yeah, 4 times. So this is just pi over 4 radians. So we changed. That was step one. Change the degrees to radians. Got it. And now step 2, we just take that and plug in for the angle theta there. So the area will be 1/2 r. What's r? I don't know. Did they tell us? There it is. Radius is 10. So pop that in. The radius is 10 squared times theta, which the angle is pi over 4 radians. So there we go. So you can just use your calculator on that. And, just take 1 divided by 2, or 0.5, whatever, times 10 times 10, 10 squared or 100, times the pi, use the pi button, divided by 4, hit equals, so pi divided by 4, I'm getting 39.2699. What are my units here? I don't remember, square centimeters. Yeah, it was in centimeters. So this is area. Area is always square units, right? Because it's the area. It's all this space in that sector there. It's that many square centimeters. That means how many little, square centimeter by centimeter squares would fill up this area. 39.2699 square centimeters. So there's the two formulas for sectors of a circle, the arc length and the area. And in both formulas, theta must be in radians.